Hi, guys, and welcome to Chapter 5 review. I know you're so excited to make it through Chapter 5. We are working on systems of linear equations and inequalities. And to prepare you for the test, I'm going to give you problems that are very similar to what you are going to find on the test. And so the first part that I want you to be able to do is look at an equation. Here's one, 5x plus 5y equals 15. And here's another one, 2x minus 2y equals 10. Now, you may say this is in standard form. I really prefer to work with slope-intercept form. You can graph these in standard form if you want to. Remember our little method where you could cover up the x. Say when x is 0, y would be 3. Okay, so you'd say 0, 3 is one of our intercepts, and then when y is 0, x would be 3. So when y is 0, x is 3. So you've just gone from standard form to your two intercepts, and we can do the same thing over here. We're going to say the first one, when x is 0, y would be a negative 5. And when we cover up y, because y is 0, we would say x would be 5. Okay, so we've just gone from standard form to our two intercepts, and then we could graph that. So when we graph that, we see it's going to intersect about right here. If my lines were perfect, you would see that it would be at this point that we would call for 1. Now, that's what we call our solution for a system of linear equations. It's that ordered pair that indicates where these two lines cross. Now, the key thing to test whether a solution is actually a solution is to take this value for x and this value for y and put it back into your original equations and do a quick check. So is 5 times 4 plus 5 times negative 1, is that equal to 15? And you'd say, yep, 20 minus 5 equals 15. So that checks out. We're going to do the same over here because it has to satisfy both sides. So this is our 4, so 2 times 4 minus a 2 times a negative 1 equals 10. So is 8 negative times a negative? Positive 2. Is 8 plus 2 10? Yes, it is. So this indeed is our solution for this system of linear equations. Okay? Now, another thing I want you to be prepared to do is to actually go from standard form and rewrite it into slope-intercept form. There is a section of the test where you will be asked to compare slopes and compare y-intercepts. Now, if you've already successfully graphed it from this standard form, you could look at this and you could say, well, yeah, I know my y-intercept is down here at 0, negative 5. And you know your slope is going to be, what did we say? Up 3 over 4. So you could write this equation as y equals 3/4 x minus 5. So if you did an accurate graph from your standard form, you could rewrite the equation in slope-intercept form. Now there is also another way to do this, okay? Now, if you go from 5x plus 5y equals 15, and you want to get y alone because you want it to be in this y equals mx plus b format, you would have to subtract 5x from both sides, and you have 5y equals negative 5x plus 15. Divide each term by 5, very important over here. So then you have y equals negative x, and that is a plus 3. Okay? Now, if we're going to rewrite this one, we have 2x minus 2y equals 10. We want to get y alone, so we're going to subtract 2x from both sides. Keeping track of this step by step is how we do algebra. Divide each term by negative 2, and then we have y equals x. 10 divided by negative 2 is going to be minus 5. Okay? So I obviously did my slope wrong here. It should be up 1, 2, 3, I didn't put this down here at -5, so it should be right there and go up like that. So this was an erroneous graph, but you can only catch that when you actually rewrite it in slope-intercept form using algebra, okay? So making sure that you are using your algebra muscles to rewrite things in slope-intercept form, then we can compare these, and we notice that they have opposite slopes, so they're perpendicular lines. And being perpendicular, we know they're going to cross and you're going to have one solution, right? And we already determined what our solution was and checked it out. So now let's talk about solving linear equations by substitution. Now, the good news on the test is that you have a whole section that says solve the system of linear equations using any method. Your options are graphing, substitution, or elimination. So I'm going to give you one here that would be 5x plus y equals -3. And then we're also going to have 3x minus 8y equals 24. Okay? We want to have one of the equations in terms of like x equals yada yada or y equals yada yada. So the easiest thing to do would be to add 5x to both sides, and then we get y equals something. And so we can then do substitution. So this is going to be 5x minus 3. So anytime we have y over here, we're going to take this 5x minus 3 and substitute it in for y. So let's do that. 3x minus 8 times 5x minus 3 equals 24. First step, use the distributive property. So 3x minus 40x -8 times -3 is going to be a positive 24 equals 24. Well, this looks better because when we subtract 24 from both sides, we get 0 equals, combine like terms, -37x. Divide by -37, and we know x equals 0. So once x equals 0, we can put it back into one of the original equations. So if we put it back into this -5 times 0 plus y equals -3, we would see that y equals -3. And that is our solution. It would be 0, -3, written as an ordered pair just like that. Now, the thing is that we need to be able to test it and make it be true in both of our original equations. So if we put it over here in this equation, we would say 3 times 0, well, that's 0. -8 times -3 would be a positive 24. So we're left with 24 equals 24. That checks out, and that is our solution. Now, I'm going to teach you how to solve linear equations by elimination. Step 1 is multiply, if necessary, one or both equations by a constant so that at least one pair of like terms has the same or opposite coefficients. Meaning you're looking for the opposite. So do you see a -4x somewhere? Or do you see a -6y somewhere? I don't. So we have to multiply one of these equations by a constant so that we end up with opposite coefficients in front of the like term. So let's shoot for a -6y in front of this. So we'll have to multiply everything by 3. And using the distributive property, we get 3x. 3 times -2y is -6x. And 3 times a -2 is a -6. So then we can write this equation right under the other one, and we're going to stack them and add them. So 3x minus 6y equals -6. So we're going to add straight down, making sure that our like terms are stacked on top of like terms, meaning our x's are stacked up, our y's are stacked up, and our constants are stacked up. So we have 7x. This cancels out, eliminating the y, hence the name elimination. We add this up, and that's -14. Divide both by 7, and we have x equals -2. Now, once we have that, we can put it back into one of the original equations. 4 times a -2 plus 6y equals -8. So we have -8 plus 6y equals -8. And we would say, hey, hey, we know that's going to be 0. So our y is equal to 0. So here's our ordered pair, -2, 0. And that has to check out in this equation too. So if we had -2 times 3, that's -6. That would be 0. Does -6 equal -6? Yes, it does. So it checks out both ways. And we've just solved that by elimination. So follow your steps. Remember, we multiplied, if necessary, by a constant. We added or subtracted the equations to eliminate one of the variables. We solved the resulting equation for the remaining variable. We went x equals -2. And then you substitute that value back into one of your original equations and solve for the other variable. Write your answer as an ordered pair. There we go. Now that you guys have learned 3 different ways to solve solutions of systems of linear equations, I want you to be able to identify some special solutions. So in a section of your test, it asks you to compare slopes and y-intercepts of the graphs of the equations to determine whether the system has one solution, where the lines intersect, no solution, meaning they're parallel, or infinitely many solutions, meaning they have the same slope and same y-intercept. So these ones are the most intriguing because they would look like 2x plus 3y equals 9. Well, if you were to take all of that and multiply it by, let's say, 2, it would look like 4x plus 6y equals 18. When you go to graph them, they are lines that stack right on top of each other. So the lines overlap, meaning that you have infinitely many solutions. So that's your quick check. If you notice, you could take one equation, multiply by a constant, and get the next equation. You're going to have infinitely many solutions to that system of equations. Now, if you end up with a situation where you have the same slope, different y-intercepts, you know they are going to be parallel and have no solution. If they have one solution, they have different y-intercepts, different slopes. Basically, if you have anything with different slopes, they are going to cross. And you are going to have one solution, which is the ordered pair x, y, where those two lines cross. And you can figure that out by elimination, substitution, or graphing. Now, this part, solving equations by graphing, is a little bit of a repeat, but the only difference is you're going to see a different format of equation come out, and you're going to see that we only have the x variable here, and that something in terms of x is set equal to something in terms of x. Well, you guys know that if a equals b and b equals c, then a equals c. And that's essentially what we have up here is our a equals c, but you're going to break it each down and set each one equal to y. So this side is going to be set equal to y equals 3x minus 1. And then this side is going to be set equal to y equals -2x plus 4. Then if you were to graph them, you would go down here 1, and you'd have a slope of 1, 1, 2, 3, up 3 over 1. So from there to there, you'd have a line that looks like that. And then if you were to graph this one, you would have a y-intercept there at 4, and you'd go down 2 over 1, and you would find that they are going to intersect right there at that place. So this is the main thing I need you to know is that you take each side, set it equal to y, graph the lines, and look for that point where they cross. And the x value is your solution. That is the only difference here is that your solution is not an ordered pair, it's just x equals some number. So here it would be x equals 1. And I know absolute value is your favorite part, and I'm going to talk you through how to do this. Remember, you're going to end up graphing 2 different systems of equations here. You're going to end up with 4 equations from this one original. So the first equation you're going to write is where you end up with the positive version of this and the positive version of this. So -x plus 4 equals 2x minus 2. We're going to draw a big line here. Then you're going to end up with the negative version of this. And it's as if you turned everything here negative. So we would keep this left side the same, -x plus 4, set it equal to a negative times everything inside the absolute value symbols there. So we'd have -x plus 4 equals a -2x plus 4, because the negative times the negative is a positive. Okay, now from that point, this looks very similar to what we had up here. You're noticing that we only have x variables. So we're going to take this side and set it equal to y. Y equals negative x plus 4. There's one equation. Then we have y equals 2x minus 2. There's another equation, and we're going to graph those two as a system of equations. Here we're going to have y equals negative x plus 4. Gee, that's the same line we have over here. But over here we're going to have y equals negative 2x plus 4. So that is different, and we end up with two different systems of equations here from this one original absolute value equation. Now, I want you to know and be able to do this, but I'm not going to have this on the test. Okay, graphing inequalities is going to be a large part of this test, and you need to be super comfortable with this. The most important thing for you to know is that you are going, not the most important, one of the first things you need to know is you're going to use a dashed line if it's greater than or less than. If it's greater than or equal to or less than or equal to, you're going to use a solid line. So first things first, know whether you're going to use a dashed or solid line. Okay, so if you are asked to graph x is greater than negative 3, you are going to look here on the coordinate plane, and you're going to say, where is x? Negative 3. So you're going to go over, there's x is negative 3. For any value of y, x is negative 3. For any value of y, x is negative 3. And you are going, oops, I put it in the wrong spot, negative 3. So you're going to do that. Now, before you fill it in, you're going to say, oh, it is greater than. So I'm going to have to use a dashed line, and it's going to look like that. Now, you have to figure out which values of x, so you're going along the x-axis, are greater than negative 3. So you would say, you know what? It's going to be this whole area over here where x is greater than negative 3. And you're also going to test a point, and you're going to say, if I pick this point 0, is 0 greater than negative 3? And if it is, then you know that you've shaded the correct region. Now, you're also going to be asked to graph some that are going to be in slope-intercept form. Almost. They're still inequalities. So your quick check is, hey, I'm going to use a dashed line. But you're going to find your y-intercept here at 2, and your slope is negative 3. So you're going to go down 3 over 1. And you're going to do your little dashed line right there, all the way up. And then you have to shade the half plane to show where y is greater than that. So you can go up the y-axis to anywhere that y is greater than that dashed line you just did and shade that in. Now you can test a point. So you could test this point where y is 4 and x is 0 and say, is 4 greater than 2? And if it checks out, then yes, you have shaded the right portion of this half plane. Now you are also going to have a system of linear inequalities where you might have this graphed, and then all of a sudden you have to graph something else, like y is greater than or equal to negative 1/2 x plus 2. Okay, so you're going to say, oop, it's going to be a solid line here. You're going to find your y-intercept here at 2, and you're going to go down 1 over 2. Down 1 over 2. And it's going to look like that. And it's going to be a solid line here. So we're going to try to create this nice solid line there. And then you have to figure out which part to shade. Now it's a different line, so you have to get a different color. And we're saying y is greater than this. So we're going to go up the y-axis and shade this whole part here. Now you're noticing this part between these two is only shaded blue. You're noticing this part is kind of shaded purple. So what we're really looking at is this area here. And again, I shouldn't be coloring in this dashed line, but I want you to see that this area that's shaded by both of them is our solution set. So it's not just where there's red, it's not just where there's blue, it's where there's both of these. So we might pick a point, don't pick a point on the line, but pick a point out here. Let's say we have 2, 3. When x is 2, y is 3. And we would put that back into our original equation and say is negative 3 times 2, it's negative 6, plus 2, that'd be a negative 4, is negative 4 less than 3? Yes, it is. So we know that is a solution, but we also have to test it in our other one to make sure it satisfies both of the equations. So 2 times a negative 1/2 would just give us a negative 1, plus 2 is going to be 1. Is 1 less than or equal to 3? Yes, it is. So we know that that spot is a solution that satisfies both equations. Yeehaw! Isn't this getting fun? So we have solved linear inequalities in two variables by graphing the boundary line, testing a point to know where to shade, graphing the next line, testing a point that is in the shaded region that's shaded by both of those. Now, when we have systems of linear inequalities, this is our final section. Your step one is to graph each inequality in the same coordinate plane. So the final thing I want you to know and be able to do is look at a graph of a system of linear inequalities and write equations to go with it. Okay, so if you look at this one, you are going to say, all right, we know that y is greater than or equal to, because it's a solid line, and we are going to look at the slope. It's going to go up 3 over 4. So you would say like 3/4 x, and then your y-intercept is at 3. Okay, so that's the equation for that line. And then you would also have to write the equation for this line. So you would say y is greater than, not equal to, right? Because we just see that dashed line. And we know our y-intercept is down here at negative 1, 2, 3, negative 3. And it looks like it goes, yeah, it looks like just a slope of, let's see, we go up 1, 2, 3, 4 over 1, 2, 3, up 4 over 3. So it would be up 4 over 3, 4/3 x minus 3. And so that would be how you write a system of linear inequations. And you would know that your solution set is really in this area right here, the area that's shaded by both of them. There you go. That is all of solving systems of linear inequations and systems of linear inequalities. I hope you guys have a great weekend and good luck on the test. Bye.